Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to be applying the knowledge of partial fractions in finding the sum of a certain sequence. So the question is asking us to find the sum from r equal to 1 to n of 1 divided by 4r squared minus 1. So the first step we have to do is to resolve this fraction into its partial fractions. And to always do that, we always begin by first of all identifying the type of fraction. This fraction is a proper fraction because the degree of the polynomial in the numerator is simply 0. It's equal to, is less than the degree of the polynomial in the denominator, which is 2. So it is a proper fraction. And with that, once it's a proper fraction, we now check the denominator if it can be reduced, meaning it can be factorized. Now, the denominator here is simply a quadratic function, and you should know that for a quadratic function to be factorized, its discriminant has to be greater than or equal to 0. So this quadratic function, the discriminant is simply equal to b squared. There is no term in r, so b is 0, minus 4 times a. Our a is 4 and our c is negative 1. This gives us 16 and it is greater than 0. So we can say that 4r squared minus 1 is reducible. Now, how do we reduce this polynomial? There are many ways to reduce it, but it is clear from here that the polynomial or the quadratic 4r squared minus 1 can be written as 2r all squared minus 1 squared, and if we perform difference of two squares, we have 2r minus 1 times 2r plus 1. So we have successfully reduced or factorized that quadratic. So it means that my fraction here becomes, now I've written 4r squared minus 1 as a product of its two linear factors. So I just replace, and since I have basically linear factors in the denominator, then the partial fraction form will simply be a on 2r plus 1. Since 2r is a linear factor, its numerator has to be or maybe you can even say 2r minus 1 and then 2r plus 1. So we need to find a constants a and b. Okay, that's what we need to find. So when you have something like this, the very first thing to do is you look for the LCM. So this is equal to, the LCM is simply 2r minus 1 times 2r plus 1. Now when you take 2r minus 1 times 2r plus 1 and you divide it with 2r minus 1, you left with 2r plus 1. You multiply with a, you have this, and you take it and divide and multiply with b, you have this. Okay, now you realize that this is a function, or this is a fraction which was equal to, okay, now realize that these two fractions, this fraction and this fraction, have the same denominator. So it suffices that we just equate their numerators and we solve for the values of the constants a and b. So if I equate their numerators, I'm going to have a to be identically equal to 1 to be identically equal to this numerator. So we can basically go by setting, though we can say expand and we equate, but to be faster, I'm going to start by setting. If I set r to be equal to half, then we have the left hand side to be 1 and the right hand side, if you replace, you have a into 2 times half is 1, then plus 1. Here 2 times half is 1 minus 1 is 0. So from here we simply get our a to be equal to half. So a is equal to half. Now if you now further set r to be negative half, then the left hand side is 1, the right hand side we have 2 times negative half is negative 1 plus 1 is 0. 2 times negative half is negative 1 minus 1 is negative 2. So b into negative 2. So this means that our b is equal to minus half. Therefore, what can we conclude? Therefore, we have gotten a partial fraction of the single fraction. So it means that this single fraction here, okay, this single fraction is just equal to, I just need to replace my a and my b in these partial fractions. So my a is half and my b is negative half. So I can just put half here and I put a minus sign here. We can even factorize the half, okay, and we have 1 divided by 2r minus 1 minus 1 divided by 2r plus 1. That is it. Okay, now after doing this, the main aim of this question is actually to compute this sum. Okay, so we have to use the knowledge of partial fractions. So follow up keenly. Now this sum itself will be equal to, now in the place of this fraction, I'm just going to replace it with its identity, which is what I've resolved, which is this. Okay, now since this half here is a constant, I'm going to pull it out of the sum. It does not depend on arrow, so I can write it as half times this sum, half times that sum. Okay, now let us replace terms and simplify. So I'll put my half outside. Okay, now when r is equal to 1, this term here becomes 1 over, I replace r with 1, the denominator becomes 1, so I just have 1 over 1 1 minus, if r is 1, I have 3 in the denominator here, so minus 1 divided by 3, plus we are summing terms. Okay, so let's go. When r is equal to 2, this becomes 4 minus 1 3, so you have 1 divided by 3 minus, when r is equal to 2, we have here 4 plus 1 5, so we have minus 1 divided by 5, plus when r is equal to 3, here we have 5, okay, so we have 1 divided by 5, minus, here we have 7, so we have 1 divided by 7, and so on and so forth. Now when r is equal to n minus 1, because I cannot write all the terms, so I'm summing from the first term to the n term, but before arriving at the n term, I will pass through the n minus 1 term. So when r is n minus 1, I'm going to replace r here with n minus 1, so I have 1 divided by 2 into n minus 1, then minus 1 minus 1 divided by 2 into n minus 1, then plus 1. Let me first of all simplify this. This whole gives me 2n minus 2. When you take minus 1, you get 2n minus 3. Now this gives me 2n minus 2. Okay, plus 1 gives you 2n minus 1. And finally, when r is equal to n, we just have 2n minus 1 here, plus 1 over, minus 1 over 2n plus 1. I'm just replacing r with n. Now if we sum this, right, you're going to see that this is a telescopic sum, and I'm going to show you why. So this sum is equal to, we have a half outside. Now you realize that negative 1/3, okay, negative 1/3 cancels with positive 1/3 when you add them together. Now negative 1/5 as well cancels with positive 1/5. Negative 1/7 cancels with, there will be a certain term here, positive 1/7, inside these 3 dots that will cancel with negative 1/7, until you're going to realize that this term here, okay, is going to cancel with a certain term in front. It means if I maybe put here was when n is equal, when r is n minus 1. If I put r to be n minus 2, you realize that this term in its denominator here becomes 2n minus 3, and there's a negative sign, so it must add up with this one to give you 0. Okay, so some terms inside here you definitely cancel. We definitely cancel with this term, and you also see that this term here, okay, will cancel. Since it's negative, you add it to itself, it becomes 0. So the only 2 terms you're left with will be the one here, this one, and the negative 1 divided by 2n plus 1. Those are the only 2 terms that are left. Okay, so you have 1 minus 1 divided by 2n plus 1. So this gives us half into, the LCM is simply 2n plus 1. So we have 2n plus 1 times 1, then minus 1. If you look for the LCM and you divide, and you write it as a single fraction, so you have half into 2n divided by 2n plus 1. So the 2 in the denominator can cancel with this 2, and at the end of the day, we can conclude that this sum is equal to n divided by 2n plus 1. Okay, so that is the value of the sum. Alright, so maybe in some other questions they can give you this type of question, and then the next question and I'll say prove by mathematical induction that this sum is actually equal to this. Okay, so maybe I'm going to do the mathematical induction in the next video. Thank you guys for watching. See you in the next video. Like the video, share the video with your friends, and subscribe to the channel.